Next problem, show that the circles x square plus y square minus xx minus 2y plus 1 equal to 0 and x square plus y square plus 2x minus 8y plus 13 equal to 0 touches each other. Find the point of contact and equation of common tangent at the point of contact. Given circles are x square plus y square minus 6x minus 2y plus 1 equal to 0, that is equation number 1. X square plus y square plus 2x minus 8y plus 13 equal to 0, that is equation number 2. Let C1 and C2 be the center of the circle 1 and 2 respectively, and small r1 and r2 are the radius of the circles 1 and 2 respectively. So 1 implies 2g1, right? We are taking 2g1, the coefficient of x, minus 6, therefore g1 equal to minus 3. Then 2f1, the coefficient of y, that is equal to minus 2, f1 equal to minus 1, and c1 is the constant term, that is equal to 1. So c1, the center of the first circle, minus g1 minus f1, that is equal to minus of minus 3 comma minus of minus 1, that is equal to 3 comma 1. And radius of the first circle r1, that is equal to root of g1 square plus f1 square minus c1, that is equal to root of minus 3 square plus 1 square minus 1, that is equal to root 9, that is equal to 3. Now 2 implies, let us take the coefficient of x, that is equal to 2g2, that is equal to 2, therefore g2 is equal to 1, and 2f2, the coefficient of y, minus 8, that is equal to, therefore f2 equal to minus 4, and c2 is the constant term, that is equal to 13. Now c2, the center of the second circle, minus g2 minus f2, that is equal to minus 1 minus of minus 4, that is equal to minus 1 comma 4. r2, the radius of the second circle, that is equal to root of g2 square plus f2 square minus c2, that is equal to root of 1 square plus minus 4 square minus 13, that is equal to root 4, that is equal to 2. Now the distance between the center of the first circle and the second circle, that is c1 c2, the length, that is equal to root of, here we are going to use the distance formula. Distance between x1 y1 and x2 y2 is equal to root of y2 minus y1 whole square plus x2 minus x1 the whole square, or x2 minus x1 the whole square plus y2 minus y1 the whole square. So that is equal to, we are taking c1, that is x1 y1 3 comma 1, and c2 that is x2 y2, that is equal to minus 1 comma 4. So minus 1 minus 3 the whole square root of, right, plus 4 minus 1 the whole square, that is equal to root of 16 plus 9, that is equal to root 25, that is equal to 5. That is equation number 3. Now the radius, sum of the radius r1, first circle radius plus the second circle radius r2, that is equal to 3 plus 2, that is equal to 5, that is 4. From 3 and 4 we are having c1 c2, the distance center between the two circles, which is equal to sum of the radius r1 r2. So c1, this is c2, the second circle, this is the distance, right? So we know if c1 c2 is equal to r1 plus r2, then the circles are touching each other at a single point, that is the point of contact between these two circles. In this case, both the internal and the external centers of similitudes exist, right? And the internal center of similitude is the point of contact of the two circles, right? Which divides c1 c2, that is the distance between the two centers, the line c1 c2, right? So this particular point of contact, that is internal center of similitude, divides c1 c2, the line c1 c2 internally in the ratio r1 is to r2. Let px comma y be the point of contact of 1 and 2, right? So this is pxy. We know that pxy, which divides the line x1 y1 and x2 y2 in the ratio m is to n internally, then the coefficient of p is given by the formula mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. Here x1 y1 is c1, that is 3 comma 4, and x2 y2 is c2 minus 1 comma 4. r1 r2, we know r1 is to r2. right? That is 3 is to 2, m is to n. So using the formula, so coordinate of the point of contact p x comma y, which is equal to 3 into minus 1 plus 2 into 3 by 3 plus 2, comma 3 into 4 plus 2 into 1 by 3 plus 2. So you will get p of x comma y, which is equal to 3 by 5 comma 14 by 5, right? So this is the circles, two circles, this is the distance. So p is the point of contact of these two circle, 3 comma 5 comma 14 comma 5, right? Now this is the common tangent, right? So now to find the equation of the common tangent at p, at the point of contact, right? Clearly the common tangent is perpendicular to the line C1P or C1C2. You can take any way. See the line joining the center, or you can take C1P. That is enough, right? Slope of C1P, that is, let it be m1, right? Now we are taking slope of C1P. You can take C1C2 also. So you will get the same answer, right? I am taking C1P, right? So we are using 2-point formula, y2 minus y1 by x2 minus x1. So 14 by 5 minus 1 by 3 by 5 minus 3, right? Therefore m1 equal to 9 by minus 12, that is equal to minus 3 by 4, right? Now slope of the common tangent. Common tangent is perpendicular to C1P because that is the radial line. So tangent is always perpendicular to that one. That is normal line, you can say, right? C1P. So tangent is always perpendicular. Normal and tangents are always mutually perpendicular to each other. So the tangent at P, right, the vertical line, right, and that is always perpendicular. So slope of that line is, suppose slope of one line is m1, then the slope of the perpendicular line is minus 1 by m1. That is the standard result we know. So slope of the common tangent is, we are taking m, that is equal to minus 1 by m1. So that is equal to, substituting the value of m1, minus 1 by 3 by 4, minus 3 by 4, that is 4 by 3, reciprocal. So since the point p 3 comma 5 comma 14 comma 5 lying on the common tangent, right, because the tangent passes through the point p, so the point is on the line and we know the slope, so we are going to use the slope find form, right, to find the equation of the tangent. So equation of the common tangent is y minus y1 equal to m into x minus x1. See here x1 y1 is the point of contact, 3 by 4 comma 14 by 5. M we know 4 by 3. Substituting all the values, so you will get y minus 14 by 5 is equal to 4 by 3 into x minus 3 by 5. So simplifying, taking LCM on left side and right side. So 5y minus 14 by 5 is equal to 4 by 3 into 5x minus 3 by 5. 5 and 5 get cancelled, right? So 5y minus 14 equal to 4 by 3 into 5x minus 3. Just to do the cross multiplication, 3 into 5y minus 14 equal to 4 into 5x minus 3. So multiplying, 15y minus 42 equal to 20x minus 12. So that is 20x minus 15y plus 30 equal to 0. So divided by 5. So each number will get divided by 5. So 20 by 5. So 4x, 15 by 5 minus 3y plus 30 by 5, 6 equal to 0, which is the required equation of the common tangent. Thanks.